Thank you so much for joining tonight's lesson. We're going to discuss a Butere Girls examination. That is Form 2. Form 2 work, together with some Form 1 work, is basically paper 1. So that's why they have indicated here, paper 1. So share this with friends so that you may invite them to our live broadcast. Number 1 is a question from logarithms, which is a Form 2 concept. We're taught to use logarithms to evaluate. It's good for you to remember that our consultation line 0704153366. So feel free to consult. Feel free to inquire more about our revision programs. Now back to the question paper, whereby we try to use logarithms to evaluate. Underline logarithms. A question which is close to this will tell you to use logarithm tables. Now that's a different setting. Use logarithm tables means that you're going to extract logarithms of values strictly from the mathematical table. While in this case, whereby you've been told to use logarithms, you are free to read logarithms from your calculator. So in this lesson now, we are free to use the calculator. Allow me tabulate my working here, whereby I'm going to have numbers, their logarithms, and the standard forms. So we're going to have a very serious explanation of how this question should be done. Remember, these are 4 marks and they should not be taken for granted. We're having the number here, then the standard form, then the logarithm of the number that way. So the first number, remember we're trying to find the cube root of 45.3. So in standard form, this number becomes 4.53 times 10 power 1. So the logarithm shall be having 2 parts, whereby we have 1, then point. Now we read, 1 here is from the 10 power 1. We call that one the characteristic. Then the mandisa will come from the log of 4.53. Now I key that one to my calculator and I'm getting 0.6561. 6561. Yeah, 6561 that way. So that is the first number. The second one is a 0.00697. 00, sorry for that interruption. 0.00697. So we are having now 6.97 times 10 raised to the power of. Now let's look at this power. We are moving 1, 2, 3 times. So -3. So now the logarithm for this number shall be bar 3 point. Remember, this is not -3. When it comes to the logarithm, it's bar 3, meaning that the negative is strictly on 3 alone and not on the whole logarithms. So now I read the log of 6.97. This gives us 0.8432. 8432. Then now, in the 2 numbers, the first 2 numbers have been multiplied. When we are multiplying numbers, we usually add their logarithm. So we should add the logarithms now. We should add the logs. Let me check the addition. I also discourage people from adding using a calculator when it comes to logarithms. Just do it manually, kindly. This will be 3. This becomes 9. Then 5 and 4, 9 also. 6 and 8, 14. So I carry 1. So 1 plus 1, but plus a -3. That will be 2 minus 3, becoming a -1, which we write it as bar 1. bar 1 that way, not -1, but bar 1. Then you skip a space so that you may not have the numbers colliding. The second number is a 0.534. This becomes 5.34 times 10 to the power of -1. So that the logarithm becomes bar 1 point. Now, I'm supposed to read the log of 5.34 from the calculator. That becomes 7275. 7275. And now that the denominator and the numerator have been divided, their logarithm should be subtracted. So the overall logarithm from the numerator and that from the denominator are supposed to be subtracted. So now I'll be subtracting these two. Yeah, I'll be subtracting these two that way. So 3 minus 5, we have to carry 1 and have 13. So 13 minus 5 is 8. Then I'm again having, because we've carried 1, we're having 8 minus 7, which is 1. 9 minus 2, which is 7. 4 minus 7. You can't subtract that. So we're supposed to carry 1 from the characteristic side. So we carry 1 to make this one a 14. 14 minus 7 is 7. Remember, on the whole number part, which we are calling the characteristic, we were having a -1 and we have borrowed 1. That means we have made it a bar 2 now. So bar 2, then minus a bar 1. Bar 2 minus -1. In other words, that becomes bar 2 plus 1, which is bar 1. Yeah, bar 1, that way. So this is the final logarithm now. This one is the final logarithm. After this, we're supposed now to look at the root there. We are carrying the square root, the cube root, sorry, of everything. To carry out any root using logarithms, we just divide the logarithm by the root. So this final logarithm should be divided by 3. Now look at it this way. We're supposed to divide this by 3. So I'm going to take it now to my right-hand side so that I may solve it there. So this becomes, remember, the characteristic part is whole number part. It should not have a decimal. So when we look at -1 and we are dividing it by 3, it is not directly divisible by 3. It will give us decimals. So we make the characteristic a multiple of 3 so that it will be independently divisible by 3. So to make -1 divisible by 3, we have to subtract 2 from -1. So when we subtract 2 from -1, we will get bar 3. We'll get bar 3. So this is what we'll be dividing by 3 now. Bar 3. Then we add the Mandisa part will also be divided by 3. But the -2 that we've borrowed, now we add it to the other side. So the characteristic side now, or the Mandisa part now, will be 2.7718 out of 3. We also divide it independently by 3. The 2 is because we borrowed 2 to make the characteristic a multiple of 3. Therefore, the 2 that we've borrowed is now added to the Mandisa part. Remember, if it was bar 2.7718 to divide by 3, we would have subtracted by 1 to make -2 divisible by 3. So to make it divisible by 3 that way, and the Mandisa part should have been that way, also over 3. So that is how we're supposed to work it out. Whatever we have subtracted from the characteristic to make it divisible by the power involved, we add it to the Mandisa part. So this becomes bar 1. Then we add 2.7718 over 3 also. We get 9239. 9239. So this is going to be bar 1.9239. That's how we divide it. Now, this is now the final logarithm, whereby for us to get the answer now, we obtain what we call anti-logarithm. To get anti-logarithm, we're supposed to know that because we are having bar 1.9239, then we should know that already here we should be having times 10 power negative 1. And that is why the logarithm is having bar 1. So we're just going backwards now. Then there is a number whose logarithm is 0.9239. Therefore, we carry what we call anti-logarithm. That one can be read from the mathematical table, but we can also go to the calculator and we write anti-logarithm, whereby we write shift log of the value that we are having there, which becomes 8.393. 8.393. So when we multiply by 10 to the power of negative 1, it shall become 0.8393. So this is now the final answer. The final answer. These are questions whereby you can even, after the working, you go to the calculator and you work out this value. Then you confirm whether you are correct. Yeah, you just confirm you're working. Yeah, and exactly, I'm correct to 4 significant figures. Using the calculator, I'm getting the same. So that's how accurate you're supposed to be. It's good for you to know that the marking of this is how you're supposed to mark this question. All logarithms, they get 1 mark, a method mark. All logarithms properly extracted, either from the calculator or a math table. Whether you add them, you divide them, whatever you do, by just reading them correctly, you get a mark. Then we have addition or subtraction. Add or subtraction of logs. You also get another mark. Then we have dealing with the power now. It can be either a power or a root. You know, you can be given everything power 3, meaning that you shall multiply the logarithm by 3. So it can be a power or a root. Working it out well, for a power you multiply, for a root you divide, get another mark. Then we talk about the answer now, which will give you the final mark. So that is how we're supposed to work out that question. Kindly subscribe to our platform, share to invite a friend so that we may keep growing together. Otherwise, I appreciate everyone. Remember to comment. Remember to like our videos. Yeah, recommend a friend to this platform. Now, given that the sine of 2/3 x plus 20 degrees equals to the cosine of 5/6x plus 10 degrees, without using a mathematical table or a calculator, determine the tan of x plus 20. Now, in an equation, which is a trigonometric in nature, like this one, whenever you see sine and cosine, and none of them has been squared, then it means we shall apply the general formula here that says whenever we have sine of a given angle being equal to the cosine of another angle, then it implies that alpha and beta are 2 complementary angles. In other words, they are adding up to 90 degrees. Whenever you see sine and cosine being used, and none of them has been squared, you know, when they get squared now, we are taken to trigonometry 3 in form 4. where there is a concept we should apply there about trigonometric identities. But for this case, whereby sine and cosine, none of them has been squared, then we conclude that the two angles there are adding up to 90. And now according to our set here, we will say 2 out of 3x plus 20, sorry for that, plus 20, then plus 5 over 6x plus 10, we're supposed to get 90. We're supposed to get 90. Remember, this is a 20. Yeah. So now we are having 90 minus 20 and minus 10. That will give us 60. The 2/3 plus the 5 over 6. This giving us 1.5 x. 1.5, the value of x. So for us to get x now, we're supposed to divide 60 by 1.5 or 1.5. And this will give us exactly 40 degrees. That means we are determining the value of tan, the tan of 20 plus x. Yeah, 20 plus x plus 20. Let me write it in the order in which it has been brought to us. So we are getting the tangent of 60 degrees. Remember, the tan of 60 degrees can be done as the tangent of the special angles, whereby it can be given in third form. Where it can be given as third form, and that is the root of 3. So the square root of 3 gives us tan 60 without even using a calculator or a mathematical table. Look at this from the question here. Mwangi truncated 7 out of 9 to 3 decimal places. Calculate the percentage error resulting from the truncating or from the truncation. So such a truncation will give error. Remember, an error can come from truncation or from rounding off, either to decimal places or to significant figures. As long as it's a round off, it will involve some round of errors. Some error. Yeah. So how do we get error? Error equals to actual value minus truncated value. So yeah, truncated value. It can be truncated, rounded off, or estimated value. So let's divide 7 over 9. So 7 divided by 9, this becomes 0.7777 recurring. 0.777777 recurring. But now, what does it mean by truncating? So Mwangi is going to truncate. That means it's going to give us 0.777. After the third decimal place, you will not consider what will be at the right-hand side. If it was a rounding off, he could have made the third 7 a 8. But in this case, where we are just truncating, then we talk about just cutting the number into the said decimal places without considering the value at the right. Therefore, error now is going to be, percentage error is given by error over actual expressed as a percentage. So we shall talk about the error in this case, whereby we have said error is given by actual minus truncated value. Then we are going to divide this one by actual. Then after that, we shall multiply by 100 for us to get the percentage error. So this one, I'm using the calculator now. Strictly the calculator. It's good to be careful and observe what you're doing here. So we need to take 7/9 minus 0.777 that way. Then whatever I'm getting now, I shall divide by 7/9. Then after this now, I multiply by 100. So I'm getting exactly 0.1%. 0.1%. So that is the percentage error. This is on errors and approximations Form 3 work. Now the figure below shows a net of a certain solid. Sketch the solid. Sketch the solid of the net. Now it's good we look at this very carefully. Remember, a net is just a solid which has been opened up. This is a solid that has been opened up. Remember, all these sides are having 3, 3. So in case we close, I will take 4/3 to be the base. I want to close it and see what kind of a figure we're going to come up with. So I can close by raising this wing together with this wing. I raise them up. Then I also raise this face. Then after that, you discover that this side is going to be open. Side is going to be open, and it will be closed by the rectangular side measuring 5/7. So at the end of the day, we're getting a solid like this. Getting a solid like this. Whereby, let me show you how to come up with the three-dimensional diagram such that you can see. It's a wedge, actually. It's a wedge that we are coming up with. It's a wedge that we coming up to. That way. Yeah, that way. Then from this, we should know that there will be a base here. Yeah, this way. That way. Then now from the top here, we can drop some lines. We check something here. We can have this one shortened a little bit. A little bit shortened. Wait. So we can drop this one to this point. Then we drop the other end. Yeah, that way. And with this now, I can grab this end that way. So you see now, I'm having all my phases now. I'm now having all my phases. That way. So now I'm having the phase here, which I may call the base is a, let me label it very well. So the upright side is going to be BF. BF that way. Or because this line is part of the base. Remember the base is A, B, C, D. Let me show you the labeling. A, B, C, D, that way. Then from CD, we can get E at this point and F at this other point, that way. So now this is the solid, which when opened, we get this net. Wow, I hope we are together in the coming up of the diagram. You first draw it in your mind. You first see the diagram in your mind, the wedge. Then now you come up with the real diagram. Yeah, remember to subscribe, remember to share, remember to invite a friend so that we may look at part B together with them. Form the quadratic equation whose roots are x equals to 5 out of 3 and x equals to 2. Give your answer in the form. Give your answer in the form provided there. So look at it this way. X equals to negative 5 out of 3. This translates to x plus 5 out of 3 equals to 0. If it is true that x equals to 5 out of 3, then if we bring the constant to the left-hand side, we shall have it added, then we remain with a 0 on the right-hand side. Again, if x equals to 2, this implies that x minus 2 is equivalent to 0. Now, following the factorization method of solving quadratic equations, we should know that before coming up with these factors, they had been factorized. So we expand them to get the expression which was expanded on our left-hand side. So x minus 2 and x plus 5 over 3 equals to 0. So now we expand x into x plus 5 over 3 plus, okay, negative 2 now. Negative 2x plus 5 over 3 equivalent to 0. Now this is x squared plus 5 out of 3 x minus 2x minus 10 over 3 equals to 0. I hope. Yeah, now we can group some terms here. 5 over 3 plus, okay, minus 2. 5 over 3 minus 2 gives us negative a third. So we are having x squared minus a third x minus 10 out of 3 equals to 0. Now this equation, for it not to have fractions, you know, actually at this point we are already correct. But it's good you wind up this way because 3 is common. We multiply all the terms by 3. That's why this becomes 3x squared minus x minus 10. When we multiply everything by 3 equals to 0. Now this is more final than what we are having previously. And actually, this would be correct if after these instructions, you are told where A, B, and C are integers. Where B and C are integers. But in this second case, it can still be correct when you are told where A, B, and C are constants. Where they are constants, where you are told that A, B, and C are constants, any of these two expressions are correct. But when integers, the final one alone is correct. Look at number 5. Yeah, I'm also checking your comments. Please make sure you are active in the lesson. You can mention how the lessons are. Just type yeah, as we continue learning together. Thank you so much for being around. Yeah, I also feel it's good I keep you posted about this poster here in support of shifting grades. You can use the till number attached, the poster here, 49 777 42. So you can use it to support our programs, and we shall keep growing together. Thank you so much for your support. Let's continue with the paper. Now it's number 5. Use completing square method to solve 2x squared plus 5x equals to -3. I must mention this to you, that quadratic equations will be applied either as word problems or directly in a question like this. So it's good for you to be equipped with the 3 methods of solving a quadratic equation. It is good for you to be equipped with all the methods, because the question can be open. You can be told to solve the following quadratic equation. That way, you are not tied to any formula. But in this case, see, in this case, you've been tied. You can only use completing the square method. So imagine yourself now being told to use the completing square method, yet you've trained yourself. You've trained yourself only to be using factorization method or the quadratic formula, which is even in the mathematical tables. So it's good to expose yourself to all the approaches. Very advisable to do that. Okay. Now, to use the completing square method, the first thing that we do is to take the constant c. Remember, a quadratic equation is usually in the form mx squared bx plus a constant equals to 0. So for our case, the equation is actually at a certain stage already, because the constant is already on the right-hand side. So what do we do? We go to the second stage, whereby we make the coefficient of x squared to be 1. So we divide everything by 2, such that we remain with x squared plus 5 over 2 x equals to -3 over 2. So we have divided everything by 2. What is the third step? We are supposed to make the left-hand side a perfect square by adding a certain constant. And how is the constant related to the other terms? The constant c is usually given by the value of b over 2 squared. Yeah, the value of b out of 2 squared. Therefore, x squared plus 5 over 2x, we're supposed to add the value of b over 2, then squared. So b already is 5 over 2. So we divide again by 2 now. The 2 in the formula now. 5 over 2 divided by 2. So 5 over 2 over 2 becomes 5 out of 4. Then we square it. Squared, this is equal to -3 over 2. Then we also add the same constant to the right-hand side, sorry. The same constant to the right-hand side. 5 over 2 squared. So this shall be x squared plus 5 over 2x plus 5 over 2 squared. I've talked about 5 over 4 because the constant should be divided by 2 first before squaring. The constant should be divided by 2 first. So 5 over 2 is what I mean. Divide by 2, then squared. So 5 over 2 divided by 2 becomes 5 over 4. Then now we square. So this will be 25 out of 16 equals 2. We can add the right-hand side, -3 out of 2, then plus 25 over 16. I'm getting 1 out of 16. That way, I'm getting 1 over 16. Now we take square root, the other stage now. We take square root of both sides. Not really. We don't take square root. We factorize the left-hand side. To factorize a perfect square means we take square root of the first part, x, then the sign that follows which is a plus, then the square root of the constant here, which is 5/4 squared. So that perfect square on the left has now been factorized. This is equivalent to 1/16. Then now we go to the other stage, which means the other stage means we take square root of both sides. So square root of the left-hand side means, because we're having x plus 5/4 squared, now we have 1. That way, that is the square root of the same factor squared, equals to the square root of 1/16 becomes plus or minus a quarter. Because a quarter squared will give us 1/16, and negative a quarter squared will also give us 1/16. So the two are both square roots. Now we get x by taking a quarter minus 5/4, or negative a quarter minus 5/4. So a quarter minus 5/4, that gives -1, or negative a quarter minus 5/4. This gives us -1.5. Yeah, -1.5. So both roots are negative in this particular case, and it's very okay. Very okay. So that's how we work out the question using the completing square method. Look at number 6. A translation vector t equals to x minus 1, 2 minus y maps a point A, 4, 6, onto A prime, 9, 12. Find the value of x and y. We're supposed to know that when we take a translation vector and we add object, we're supposed to get image. So a translation vector, let's say it has unknown values. When we add A, 4, 6, I'm changing A to a column vector also. We should get A prime, which is 9, 12. So the value of A is going to be, we deal with the x components now. A plus 4 equals to 9. So we take 4 to the right, where it to be subtracted, and that will give us 5. Then to remain with B, we're supposed to say on the y components, B plus 6 equals to 12. So how do we remain with B? By taking 6 to the right, whereby it will be 12 minus 6, giving us 6. So the translation vector equals to 5, 6, which was involved. 5, 6 is the translation vector which was involved. Therefore, now we are told that t equals to x minus 1, 2 minus y. Therefore, we are able to say, because we know the value on the x component, then x minus 1 should give us 5, implying that the value of x equals to 6. Again, 2 minus y should give us 6, implying that the value of y, when we take it to the right-hand side to be positive, will be 2 minus 6. You know, 2 minus 6 is -4. Yeah, so I hope that one is well understood. So we have the values of x and the values of y. Values of x and the values of y. That is it. That is how you're supposed to play with those values. Now we are having an inequality here in number 7. It's my hope that you guys are learning something tonight. It's my hope that you guys are benefiting from shifting grades. online school. Number 7, it's from inequalities. Find all the integral values of x, satisfy the inequality. 3 into brackets 1 plus x less than 5x minus 14 less than x plus 46. So we're supposed now to rearrange until we get 2 simple statements, then we solve them. So the first linear inequality shall run from the first term all the way to just before. Yeah, that way. So that is the first inequality. So we write 3x plus 3 into x plus 1, which becomes 3 plus 3x after opening the brackets, less than 5x minus 14. Then the second one now is going to run just after the first inequality from 5x all the way to 46. Yeah, all the way to 46. So we are talking of 5x minus 14 less than x plus 46. That way. So those are the inequalities that we are solving. So from the first one, this is 1, this is 2. We begin by grouping terms together, whereby we can have less than. Then we talk about 5x minus 3x. When we take 3x to the right, this one now to the right, it will be 2x that way. Then 14 should be added to the right. 14 should be added to the right because it's a negative. It's a negative here. So when taken to the left, it should be added. So 3 plus 14. This is going to give us exactly 17. So to remain with x here, we divide 17 by 2, giving us 8.5. That is the first simple statement. What about the second one? We also group terms again. We group terms again. So we're supposed to have x taken to the left, whereby 5x, we subtract x. That will be 4x less than 14, which is negative here, should be added to the right. 46 plus 14. This gives us exactly 60. So when we talk about 60 now, divided by 4, this will give us 15. So we'll be talking about x less than 15. Yeah. So you see now, x is greater than 8.5, but x is less than 15. Therefore, we can come up with a compound statement whereby with x here, we know we should have 15 on this upper side, but on the lower side, according to the first simplified inequality, all the way from 8.5. So we have the values of 8, the values of x running from 8.5 all the way to 15. So we can state integral values between 8.9, 8.5, sorry, and 15. Remember, we are not having less than or equal to. We are not having this one. So the limits are not part. The limits are not part of the integral values. The limits are not part of the integral values. You should know that. Again, decimals are not part of the integral values. Fractions are not part of integral values, but 0 is an integral value. So you're supposed to know that in this case now, when you are stating, even if we had this, 8.5 cannot be treated as an integral value. It is not an integral values. It is not an integral value. So between 8.5 now and 15, we will have 9 there. We will talk about 10, 11, 12, 13, and 14, because 15 is not included. When if it's an integral value, it's an integer, it is not inclusive. It's just a boundary. It's just the upper boundary. So we will not write 15. In case you write 15, you shall have it wrong. In a question like number 8, I usually encourage learners to solve the numerator first, then the denominator, then a combination. Look at it this way. 4x squared minus 16y squared is what we call a difference of two squares. And we said this during quadratic expressions and equations. Whenever we have two squares subtracted, a minus b squared, we take a minus b, a plus b. Now, the difference of two squares will have been factorized. So from this, the numerator, which is 4x squared minus 16y squared, will be, let me write my squaring well, will be equal to 2x minus 4y into 2x plus 4y. Now, in case we expand 2x minus 4y, 2x plus 4y, we shall expand it, get 4x squared minus 16y squared. So that's how we expand a difference of two squares. Then look at the denominator now. The denominator is what we call a quadratic expression now. Now, with a quadratic expression, for you to factorize it, we're supposed to have a product which is equal to a times c. So 6 times a negative 8. 6 times a negative 8. That will give us negative 48, right? Yeah, negative 48. So with negative 48, we can also take sum of b, which is negative 8. So which terms should be multiplied to give us negative 48 and added to give us negative 8? Some students will have a challenge of identifying the factors there. And I would challenge you to be factorizing the product. Just use factorization and you discover that it's very easy. So negative 12 and 4. When you add, you get negative 8. When you multiply, you get negative 48. So now we can use them to replace negative 8xy. 6x squared minus 12xy plus 4xy. So I've just split negative 8xy into negative 12 and positive 4. So I've not changed the meaning of the statement. I didn't change, just re-expressed. Okay, from the first two, I can factor out something here, which is a 6x. To remain with x minus 2y, right? Then from the other two, 4y is common from the last two. So that will remain with x minus 2y again. Now, from the inside of the brackets, I'm having x minus 2y. And from outside the brackets, I'm having 6 plus 4y that way. So now we can combine our simplified numerator and the denominator. Our simplified numerator and denominator. Yeah. So from the numerator, we can talk about something like 2x minus 4y. That's how it is. Then 2x plus 4y divided by the numerator, the denominator x minus 2y into 6x plus 4y that way. Now, from the numerator, in the first factor, if I factorize 2, then I shall have x minus 2y. And we have 2x here plus 4y that way. Divide by x minus 2y into 6x plus 4y that way. So we can have now this one and this one cancelling, so that we have 2 into 2x plus 4y out of 6x plus 4y. Now, from the denominator and numerator, there is something that we can factor out. Look at the 2 which can be factorized. Look at the 2 which can be factorized here, so that you have 3x plus 2y that way. Then these 2 cancels with this one. Allow me now move to the left-hand side of this working space. Sorry. Yeah, sorry for that. Now, moving to this side, from the numerator, we can factorize again a 2 there. X plus 2y. Divide by, from the denominator, 3x plus 2y. So this one now will act as the most simplified answer. The most simplified answer. It's good for you to remember that you can even initiate the cancellation from the initial stages, whereby you make the numerator very simple by factoring out 4 x squared minus x squared minus 4 y squared. And you see it's still a difference of 2 squares inside the brackets, so that you factorize further from inside the bracket. They will still simplify to the same thing. Yeah, they will simplify to the same thing. And you also, after this, you also divide, you factorize 2 again from the denominator, whereby it will become 3x squared minus 4xy minus 4y squared minus 4y squared that way. Yeah, so then now you expand what is inside the bracket. You discover the 2's here can cancel in advance to have our 2 coming there. Then you solve. You shall find yourself at the same answers. Yeah, thank you. Thank you for following. I can see you're watching us. Please remember to subscribe. Remember to share, to invite a friend. Yeah. Given that 4.5 liters of water, then the density of water is given as 1 gram per cubic centimeter, was mixed with 12 liters of alcohol. Density 0.8 grams per cubic centimeter. Calculate the density of the mixture. All right, density of mixture. How do we get density of mixture? A very simple question from measurement in physics and also in mathematics. Density of mixture will always be given by mass of mixture divided by total volume of mixture. Yeah, divided by total volume of the mixture. Now, with this in our minds, we can proceed with a lot of precision, because we know now what we are doing. Mass of the mixture. You know, we need to get mass of water alone, then mass of alcohol alone, then we get total mass. It's again good to know that we are given capacities. So we convert capacities to volumes. We know that 1 liter equals to 1,000 cubic centimeters. Yeah, 1,000 cubic centimeters. So this one is going to be 4,500 cubic centimeters of water being mixed with 12,000 cubic centimeters of alcohol. You see that? So now with this, we're supposed to say again that mass is usually given by density times volume. Therefore, mass of water will be 4,500 multiplied by 1 gram per cubic centimeter, giving us a mass equivalent to 4,500 grams. Then we can also talk about a mass of the alcohol, which will be 1,200 times 0.8. What do we get here? 12,000 multiplied by 0.8. This gives us 9,600 grams. What about total mass of the mixture? This will come from the addition of 4,500 and 9,600. That's 14,100 grams. Now, this is a total mass. Total mass. With the total mass, we can talk about total volume. Of this mixture. Total volume of mixture shall be, we have 4,500 cubic centimeters and also 1,200 cubic centimeters, water and alcohol respectively. So 4,500 and 12,000 is giving us 16,500 cubic centimeters. Now with this, we ask ourselves, we are having the formula already for density of this mixture. So we need to substitute now in the first formula here. Total mass is being 1,400 out of 16,500. So when we divide 14,100 out of 16,500, we are getting 0.8545 grams per cubic centimeter. Yeah, grams per cubic centimeter. So we are having density of the mixture. Even from the look of things, you see, the density of the mixture is now somewhere between the two densities mixed. We have a density of 1 gram per cubic centimeter, another density of 0.8. So we should arrive at a density which is in between the two values, but closer to the volume, which closer to the density of the substance that had a bigger volume. So you see, we had much of the alcohol. That is why we are closer to 0.8 than we are to 1. In case the much volume was from water, then we would be having a density closer to 1 than it is to 0.8. Closer to 1 than it is to 0.8. Number 10 now. Yeah, number 10, let me continue marking. Just a reminder for you to subscribe, for you to share with friends. Just invite them. Invite somebody to the broadcast. Invite somebody to our today's lesson. It's my hope that you guys are learning a lot. The surfaces of two cylindrical water tanks are 50 square centimeters and 162 square centimeters respectively. Given that the volume of water in the second tank is 36,450 cubic centimeters, find the volume of water in the second tank if it is full. Given that the volume of water in the second tank is, so I hope this is a second tank when full. Second tank when full. But now we are finding for the first tank when it is, the concepts here now are increasing. But let's deal with measurement first, similarities and enlargements. We know that when the ratios of areas are related, whether surface area, base areas, curved areas, surface areas, or simply area, we relate them to get area scale factor. So area scale factor equals to 50 over 162. This can simplify to 25 out of 81. It's good for you to know that because we are asked about volumes, we cannot relate area and volume directly. We must link them through what we call linear scale factor. So the linear scale factor will be the square root of area scale factor, which will be 5 out of 9. 5 out of 9. Now that we are having linear scale factor, we can talk about volume scale factor, which will be when we cube linear scale factor, we should get volume scale factor. So cubing 5 gives us 125. Cubing 9 gives us 729. That way. So we have the volume scale factor as 125 out of 729. That way. Then with this now, we are again told to find now the volume. No, the volume of the second tank is given. And according to the surfaces, the second tank is the bigger one. So getting volume of the first tank, which is the smaller one, we're supposed to decrease 36,450 by multiplying it with 125 out of 729. Now, in case you wanted volume of the bigger, when that of the smaller has been provided, we would have multiplied such that we increase the value. So the first tank is the smaller one. So it has a volume of 36,450 multiplied by 125 out of 729. This gives us exactly 6250 cubic centimeters. This one now is for the first tank, which is the smaller tank. But now we are told it is R full. So R full will be R multiplied by the total volume of this tank. So we have to divide this by 2 at the end of the day. This gives us 3125. Yeah, so the language in this one has really been concentrated, but you people should be able to maneuver through and come up with right answers to all the questions. Right answers to all the questions. At number 11 now, the interior angles of an octagon. An octagon is a 8-sided. Yeah, 8-sided figure. It's called octagon. So you should know polygons together with their names. Now they are given here. 70, 90, X, 1.5, 130, 80, 1.75, then 200. Find the value of the largest angle. So we're supposed to know something that when the interior angles of a given regular polygon, okay, regular or irregular, when they are added, they should give us a certain number of degrees. So interior, sum of I, interior angles, should be 180 into n minus 2, whereby n is the number of sides. So we are talking about 180 into 8 minus 2. And this will give us, when we take 180 multiplied by 6, we are getting 1080. So all the angles inside this octagon are supposed to give us 1080 degrees. So when we take 70, we add 90, we add X, we add 1.5x, we add 130, we add 80, we add 1.75x, we add 200, we should